And go. Hello, everyone, and welcome to the Cloud Chronicles. I'm Joey D'Antoni, and I'm here with my colleague, John Morehouse. I'm Principal Cloud Architect at DesignMine. And today we're going to talk about Azure Storage. Not all of Azure Storage, mind you. We're going to talk about Azure Managed Disk and storage options that are made for virtual machines. This is opposed to the Azure Blob Storage, because you can use that for, backups, but you can also use that in your application. And you might not know this, but there's also Azure Queue Storage, Azure Table Storage, and Azure File Storage. We're not going to talk about any of those today. Outside of that, we're going to kind of talk about, we might talk about Blob Storage a little bit because it's important with backups.
Well, Blob Storage used to be a part of this way back.
Yeah, and it probably still is. And with that, I'm going to hand off to John, who's going to tell you a little bit more about Managed Disk.
Hi, I'm John Morehouse. I'm a principal consultant with D'Antoni and Associates. Managed disks are awesome. They have come a long way over the past couple of years. We're going to talk about decade. Okay, well, so I don't want to show my age. All right, it's bad enough I got gray in the beard, so I don't want to go back that far. Managed disks we use with virtual machines in Azure, and there's different things you can do with managed disks to help your performance and increase productivity, but really cool things that we can do and help save costs. But there's actually tricks that we can do with managed disks to help lower your costs over time.
Yeah. And one of the things I want to do too, and we'll mention it throughout this, we'll do some compare and contrast with AWS, because this is one of those places where things are very similar. They just have slightly different names. I did a big AWS storage assessment for a software vendor last year, and I was surprised at how similar everything was, and really, frankly, how similar the perf numbers were. But I think there's only so many ways to write things. I used to say spinny disk, but now it's because almost everything's an SSD.
Yeah.
All right. So you may ask, why do we have managed disk, and why was this such an evolution? Back in the bad old days of Azure, things were really different. It was almost like you have to take a step back and think about how Microsoft and to an extent Amazon were both just shops full of developers that were trying to build infrastructure. I'm sure there were some infrastructure people on the teams, but they had limited experience building the kinds of infrastructure we had in on-premises data centers. And one of the things we had to do, and this was really weird, if you've used a blob storage account, you'll know that it's got a domain account name .bob.core.windows.net / the name of your container. Container is effectively a folder, but under the hood, it works out to be a logical storage partition. Before managed disk, what we had to do was create a storage account, and then we would place VHD files in that storage account, and that was the disk for our VMs. And also, there were a lot of limits on those in terms of like how many IOPS a given storage account could do, this might have even been pre-premium storage. I think it was pre-premium storage. So the disks were really slow anyway. But there were a lot of limitations on like how many disks could be in a storage account, how many storage accounts you could have in a subscription. All of these things were real challenges, especially to larger organizations. Anything else, John, you care to think of?
No, other than, I mean, there's still a limit on storage accounts in your subscription today, so that limit still exists. Thankfully, honestly, I've only had to experience that architecture once or twice. Shortly after I got into Azure, they had shifted to managed disks, which is our topic today. So thankfully, I did not have to deal with those pain points for that long. It was not fun, I'll tell you.
And it's still a VHD and a storage account under the hood. It's just managed by Microsoft, and you don't have to deal with it. So one of the things that was really interesting, and I didn't know this either until like just about the time storage accounts or managed disks were kind of fully rolled out, was there's an availability component to this too. Because before managed disk, if you define 2 VMs to be in an availability set, and what an availability set means in Azure is the 2 VMs that you've put into an availability set just are never deployed to the same rack effectively.
Yep.
So that it doesn't grant you any availability. Your app has to have availability, like SQL Server AGs or web servers that have a load balancer. But with storage accounts, both of those disks to VMs could potentially be in the same storage stamp. even if they were in two different storage accounts. And that's one of the main reasons why they moved to managed disk, was to increase availability, because it was a single point of failure. And speaking as a longtime DBA, having storage as a single point of failure is a bad thing.
Well, and thankfully, managed disks now are actually virtualized disks.
Yeah.
Right. And so that's how they get that high availability, is that your disk underneath that VM is actually virtualized across many storage stamps behind the scenes.
Yeah.
So that's how they get that high availability now.
Yeah.
Which I think is to me, conceptually, that's a mind-blowing. We virtualized hard drives.
Yeah, I remember the first time I heard storage virtualization and network virtualization. I was like, how the hell do you virtualize a network?
Yeah.
Don't you need cables? But yeah, it starts to make sense. It starts to make sense eventually, and it does. If it doesn't make sense to you, it doesn't matter. You just use a managed disk.
Yeah.
I don't even. I think they finally took out where you could add a VM from a storage account like a couple of years ago. It was still there. It was like you had to do something weird to get to it, and when you're building a VM in the portal.
I still see some reference to like unmanaged disks.
Yeah.
But it's very, very sparse, right? They've eliminated that kind of concept from the doc.
I really haven't seen one. So we have several types of managed disk, and I'm going to walk through these, and then John's going to talk about some use cases. The first thing I want to mention is there are two types of standard storage. There's standard hard disk and there's standard SSD. Both of these are really non-viable for I/O intensive workloads. They have roughly the same performance numbers. I think it's like 500 IOPS, which is pretty low. The one difference is standard SSDs have a performance SLA. Premium or standard HDDs have no performance SLA. In my experience with standard HDDs, I use them to do demos of what slow storage is like for SQL Server. So don't use them for database workloads. Standard SSD, you can probably get away with something like a domain controller where it does a little bit of I/O, and you want to have a better performance experience, but it's not I/O sensitive. That brings us to the three main types of disk workloads we focus on, which is premium disk V2, and then Ultra Disk. Premium was the first SSD option that came into Azure several years ago, probably about 8 or 9 years ago now.
They've been around for a while.
Yeah. It started to give us decent IOPS. Maybe not enough if you have a big shiny orange storage array that's connected by a very thick fiber cable to a physical server. Wasn't going to get you those numbers, but it was going to get you pretty good numbers. I've built some pretty complex solutions that had 5 to 10 milliseconds of latency, and I was pretty happy with it. Ultra Disk kind of blew that out. Ultra Disk cost about 4 times what a premium disk costs for the same a premium V1 SSD cost. Performance numbers. Premium V2 is really interesting because it's built on the same platform as Ultra Disk. It gets a little kneecap, like it doesn't have the same high numbers as Ultra Disk, but it's also about 30% cheaper than Premium, and it performs better than Premium. And I'll let John talk through some of the scenarios where you might use each of these. And don't forget to mention local storage.
Mention what?
Local storage.
Oh, like in federal?
Yeah.
Oh. Well, and V2, how long has V2 been out?
I want to say about 2 years now. We're recording this in November.
About a year, 18 months.
That's 18 months sounds right. I remember, it wasn't really heralded. I just happened to be doing a training or something, or prepping for a training, and I read about it, and then I emailed our friends on the SQL Server VM team at the time, and they were like, yeah, you're right, that's going to be really awesome.
Well, and so, to your point, like the older HDDs, we would use for like non-production stuff, right? Because they're slower, no SLAs. And so we've used the premium SSDs for a long time for production workloads, right? The downside is that they are not necessarily scalable. So you had to do things like adding them to storage spaces to get better performance, right? Which caused additional overhead to actually manage capacity and performance. But premium SSDs are very prevalent in today's world still in Azure. Most of my clients are still running premium SSDs because we can't get to premium V2s, which offers not only ultra-like performance, but we have the ability to scale capacity and I/O dynamically through the portal, which is fantastic, which is really, really cool.
And now size.
and now size.
That's a pretty big.
That's which is a great thing, because now customers can dynamically scale their stuff up when they need to meet demand. I don't think that you can't scale down, I assume, in capacity, right? You scaled up, you can't scale down.
You can't scale down capacity.
Yeah.
They'll block that out.
Yeah, because we don't want to. You run the risk of deleting data if you try to scale down, and Microsoft's not going to let you to do that. But I've never seen. How many customers do you have running UltraDisk?
One customer rolled it out. We ended up pulling it back because they weren't really seeing any benefit from it. And there was that other customer I had a couple years ago that was the big software vendor in Redmond. And they let us, we used UltraDisk a lot there.
I've never had a customer use UltraDisk. In part because of the price.
The use cases, like in SQL or Oracle for UltraDisk, the use cases are really strictly for the transaction log, or in Oracle, the redo log.
Because we could argue, well, at least I think arguably the transaction log is one of the most critical. Probably the most latency sensitive in the MDF itself.
It's the most latency sensitive piece of the database.
Well, that too. Right. So using V2s or UltraDisks for your transaction log totally makes sense. Now, of course, and you also, I think you brought it up, an ephemeral disk, locally attached SSDs, which is great for like TempDB. Obviously, when you reboot the virtual machine, that ephemeral drive, not temporal, ephemeral drive gets rebuilt every time you reboot. So TempDB functions that way in SQL. It's a great spot for it.
Yeah, and that drive, just in case you didn't know, that gets mounted as the D drive in Windows, and in Linux it's SDB1, and that's a local NVMe drive that's physically in the machine. So it's almost like if you remember the days of Fusion IO or Intel Optane, it's one of those. And based on the size of your VM, you get a bigger chunk of whatever that drive is in the machine. I think in Azure, I think it's only ever one. It's only ever presented as one volume. I haven't rolled out a really giant VM in a long time. I know in Amazon on some of the larger VM types, it's presented as multiple disk.
Yeah,
and in Azure, it's always presented as a single.
I've never seen it presented as more than one volume in Azure, but you are correct. In AWS, it can be multiple volumes. Which in that case, if you're running in AWS on an EC2, you have to make sure that you stripe those volumes together. Otherwise, you lose out on performance.
There is actually a whole series of VMs too that are really focused around ephemeral storage. It's the LV2 series, and those all have NVMe drives. And at the time, the IOPS numbers that were there were crazy because it's like 100,000 and something IOPS. But now there are VMs in like the EDB SV5 series, and there's a new series called the FX something V3 that can go to like 400,000 IOPS, and an UltraDisk can go to 400,000 IOPS. That's the upper limit. The upper limit on Premium V2 is 120K IOPS, I think. And Premium V1 is a little weird because it's depending on how many stripes you make, or how many disks you stripe together, I should say. Like John was saying, you can use storage spaces in Windows, or if you're on Linux, you can use a logical volume manager to stripe those disks. And typically you run out of disks that you can allocate to the VM before you run out of IO. The old premium model, the main disk I used for most of my customers was this. It's called the P30. It was 5,000. It's 5,000 terabytes, 250 megabytes per second.
5,000 IOPS.
5,000 IOPS, 1 terabyte, not
1 terabyte.
Terabytes. Thank you. That would be cool.
That would be cool. That's a lot of storage.
But what would happen and I've done this before, where I allocated like 5 terabytes of storage for a very busy 500 gigabyte database. So that's the nice part about V2. You don't have to do that. You would just allocate the 25,000 IOPS to like 1 terabyte V2 disk for a busy 500 gig database.
So, but you could though. You could put 2 V2 disks into a storage space, right? And
there are some scenarios where you can do that. And one thing to note too, and we not really talking about VMs, but we kind of have to. There's a limit on how many IOPS your VM can do.
Yep.
So most of the time, it doesn't make sense to allocate more than the VM's available IOPS to it. Like if a VM can do 100,000 IOPS, it doesn't make sense to allocate more than that to a given disk, or to all of your disk. What I have run into though, at my big data warehousing client, was they allocated more IOPS than the VM could do in total, not to an individual disk, but what it was, let's just say for argument's sake, the VM could do 100. They had like 380K disk because they wanted, if one of the, they wanted to maximize the IO on each disk because all three probably wouldn't be peaking at this. They knew all three wouldn't be peaking at the same time. And that way they were able to maximize the IO. So there are some interesting strategies there. The portal will throw a warning if you allocate more IOPS than the machine can do. So you generally don't want to do that because you're wasting money, but there are times where it can be beneficial. So keep that in mind.
I always found that interesting to find that balance of using premium SSD of, okay, this VM can take 16 data disks. How do we balance the capacity needs versus the IO needs and allow for headroom, right?
Yeah.
Because once you hit that 16, you're done. Like you can't add more disks to expand, and you got to do something else. I always found that process of trying to find that right balance of, okay, we're going to start with 8 disks and grow and whatever. So I'm really happy that V2 came out because now we have more capacity and more flexibility with doing that.
Yeah. So let's talk about some of the features that disk have. Have you worked with snapshots and backups at all?
I have, and those have also come a long way, right? Because so now you can take a snapshot with the virtual machine online, whereas not too long ago you had to actually shut the virtual machine down in order to take a snapshot of the disk, right? And that snapshot, in my head, anyways, is just like taking a snapshot of the VM itself, right? In the virtualization world, you could take a snapshot of the entire VM at that point in time. In this case, we're taking snapshots of the actual disk behind the scenes. Then you can do stuff with that snapshot, like rebuild another machine. You can build another disk off that snapshot and use it to clone virtual machines or drives into other virtual machines in other regions or other locations.
I had a customer where they get this database log shipped to them. It's like a 13 terabyte database, or it's probably 15 now.
That's a big database.
And yeah, they didn't want to have to deal with they wanted another copy of the database in development, and they didn't want to have to deal with, because it's coming from a vendor, and they didn't want to have to deal with getting a new copy of the full and getting all that synced. So it was like, we'll try this and we'll see if it works. So I stopped SQL because you should probably, if you have a database server and you want to take a snapshot and you want it to come up clean, you should probably stop the engine. It might work, it might not. You never know. But if you want to make sure it comes up clean, do that. So I stopped the engine and took the snapshot. It takes a long time for one of those snapshots to populate when it's like 15 terabytes, or hydrate is the term they'd use, which means to make it usable. So it takes about 30 minutes for that to populate. 30 minutes later, though, that disk was available, mounted it to another VM, and got the database log shipped and synced, within 20, 30 minutes. It was really impressive. I don't think the snapshots in Azure are as good as, say, if you have a storage array or something like that does. I know we keep hyping Pure, but we have friends that work there. Their snapshots are really awesome and they work quickly. It's not that, but you can do a lot of things like that. And then backups. That was another thing with storage accounts. VM backup didn't exist until like 2015, and that's something that's really hard for people to believe. But yeah, you couldn't just back up VMs.
Now we can.
Now we can. And a lot of times we tell customers not to with SQL Server, though, because it's really an interesting conundrum there. SQL Server, I said we weren't going to talk much about blob storage, but we are. One thing you may not want to do that you've done on-prem is have a disk allocated to backups that's attached to your VM. There's a couple reasons for that. The storage is more expensive to do it that way. One. Number two, your VMs has a limited amount of IOPS that I can do at any given time. And if you're backing up locally, backup is both a read and write intensive operation in terms of IO. So you're going to be effectively crippling your VM during a backup cycle. And what you can do, SQL Server 2022 supports backup to URL in Azure or backup to S3 in AWS, but all the way back to SQL 2012 R2, SQL 2012 R2 didn't exist. SQL 2012 SP2 CU12, I think, or maybe CU1, SP1 CU12. Some unsupported version, it doesn't matter now. Because if you're still running it, you're kind of SOL. Supported backup to Azure. And in backing up to Azure, you still take that read hit, but you're storing on much cheaper blob storage for your backups. And it works pretty well. I've backed up and restored, multi-terabyte databases and within an hour.
Even writing from on-premises to Azure Blob Storage for that purpose is actually pretty quick. And if you're on an Azure VM running managed disks underneath that VM, it's even faster. Is what my experience has been, anyways.
I did have this one scenario that I don't recommend doing. I was I was trying to do mirrored backups to on-prem and Azure. That didn't work so well. It worked. Actually, I take that back. It failed about half the time. But for some reason, taking a backup locally and then copying the file to Azure was like 100 times faster than doing a mirrored backup. I don't know why a mirrored backup was so slow. It wasn't enough that I'd really call it a bug, but
I don't think I've ever used mirrored backup in a production scenario.
this is I thought I was going to be clever, and it didn't work well.
It didn't work out.
Yeah.
But I wanted to point out also that you mentioned taking that snapshot and hydrating that snapshot, that you hydrated 15 terabytes in 30 minutes.
Yeah.
Like, I remember when I first started my IT career, where, I mean, 15 terabytes was one. And even the thought of hydrating 15 terabytes in 30 minutes, it would take weeks back then. I'm not going to tell you when I started in IT, but weeks to hydrate that. I find that fascinating that we're down to that. You can hydrate a snapshot in 15 minutes, 15 terabytes.
When I started in IT, I don't think we had a SAN. So
we had the IBM disk, right? Direct attached, but it was an array. You know, it wasn't actual SAN because it was directly attached to an actual machine. That was our SAN, right?
Yeah. So one of the other things we should cover here is monitoring. You can monitor at disk, just an Azure monitor. It will show you the workload operations. As always, and I've said this about storage for a long time, you want to make sure you're looking at it from kind of every level. It's good to look at those external monitors because you can see what the disk is actually seeing, but it's also good to look inside of your workloads and look at those latency metrics.
Well, and another real quick is that, like, if you start to look at Premium V2, it's not available everywhere. And so, like, you need to, if you are interested in using Premium V2 as a storage option, you just need to double check the documents to make sure it's available in your region.
I'll put a link in the show notes to our GitHub, to your GitHub, because we have a PowerShell script you can run that'll show you what regions Managed Disk V2 is available in and what availability zones as well. And it's a like one line PowerShell script, but it's pretty handy.
There are some other limitations, like your VM has to be zonal right now.
Yeah,
you have a zonal VM to make that work. There are some encryption limitations with Premium V2, but just do your due diligence to make sure it's going to work for your solution. But we highly recommend V2s moving forward. Even like, have you moved any clients from like Premium SSD to V2?
Yes, but not like in a migration sense. When we did it, we went into new VMs.
Okay, but did you move specifically to get to V2, or did you migrate?
Yeah, for sure.
That's awesome.
Yeah, we also, and it was hard to do a direct comparison because we switched workloads, or we switched VMs because we were on some really big MVMs and we went to the double sprinkles. We also, excuse me, we went from having like 1.7 terabytes of memory to like 600. And frankly, the I/O performance wasn't that impacted. It was impacted slightly, but we were able to live with it for what it cost. And we were able to kind of support that by increasing the I/O on the disk to buffer for having less memory. So we've talked a little bit about resizing. And one of the things I don't think we've mentioned is that with V2 disk, you can performance scale at any time. So if you know your workloads are busy during a particular end of month, you can scale up that storage performance. I don't inherently see people doing that in prod because we typically design prod systems around peak storage utilization. But where that can be really good is if you have a dev test environment, and when that environment's dev, you don't need a lot of I/O performance because you're just writing code. But when you want to test and run unit test against that code to see what the performance is like, you can then like scale it up to match production, run your test, and then scale it back down. And I think that piece is actually pretty novel.
And one thing that we haven't talked about either is cost.
Yeah.
Right. I think that just looking at the pricing table for and what I see normally is disks starting out at like 1 terabyte, which is roughly $125 a month.
For a P30 for V2, it's about 90. Like at the same, yeah, the same spec, it's like 95.
So V2 is actually a little bit cheaper than premium SSD.
Yeah, and I don't think that's an accident. I think Microsoft is actively trying to get people to migrate off of V1 because then with Ultra and V2 sharing a storage platform, they're probably wanting to get those older disk stamps out of their data centers. That's my assumption. I'm not breaking NDA there. I just can do math.
Well, I mean, that kind of makes sense. I wonder, and again, no, I have no knowledge of this whatsoever, but I'd be curious if they get off of premium, if that pricing structure will change and go, but like move V2 up to where SSDs are now.
My suspicion is probably.
Probably. Well, shareholders will love that, I'm sure.
Yeah, as a shareholder, I would like that.
I mean, it's also worth noting though, you can do reservations on managed disks.
You don't save a whole lot there. The profit margins on managed disks are not that high.
You don't, but it's there as a cost saving measure. And, you know, and one of the tricks I think we mentioned it earlier was if you have you can actually tier your disks down, right? So like I've got demo machines that I'll run on premium V2s or premium SSDs, and when I'm not using them, I'll actually tier them down to like standard hard drives.
For sure, and there's a script that does that in the DCAC GitHub repo. I know because I wrote it. So you do have to power down the machines to tier them down, but that is another cost saving thing there. Let's talk a little bit about HA and DR. We mentioned availability sets, and you mentioned availability zones being required for premium disk V2. I think if you're not familiar, John, do you want to explain availability zones? I explained availability sets.
Sure. So availability zones are basically, and most of the regions have, and let me back up. Within each region that supports zones, usually there are 3 individual zones, and those zones are independently powered and cooled and physically isolated from each other. And usually it's more than 10, 20 miles, right? What I've always heard and read was usually each zone within that region is 150 miles minimum away from each other.
No, it's less than that. You're 10 miles. Yeah, it's 10 miles because the latency boundary is 15 microseconds.
Right, but it's individually isolated data centers from each other.
Correct.
Right.
The other thing you didn't mention is different network providers.
Oh yeah, I mean, but everything's isolated and independent of each other, so that way, if one fails, the other 2 are not impacted or should not be impacted unless it's a regional failure. Then you're really hopefully you have DR in Azure, which we'll get to eventually, I'm sure, in a video. And so you can specify my virtual machine to be zone redundant in the sense that if I tell it to live in zone 1, it'll actually replicate those disks in the VM to a different zone. If zone 1 dies, then I would come online automatically in that secondary zone within that region. So that's what zone redundancy means.
Yeah, and John mentioned DR there, and in our last video was on Azure Site Recovery, and one of the things that was a big limitation of Managed Disk V2. Managed Disk V2 had a lot of limitations when it came out. The performance was amazing, but man, the limitations. It didn't support Azure Backup, and it didn't support Azure Site Recovery. And in the last, I think, 6 months, both of those have gone away. And we mentioned earlier, you can do online disk resize, which you can do now, thankfully. But yeah, so all of these things pretty much work with Azure Site Recovery, and Azure Site Recovery kind of works at the unit of the disk, so it can read the disk. So just to wrap up towards the end of this, Managed Disks make using Azure VMs pretty simple. It's really easy. The one thing you really need to know is you need to understand your work, especially if you're migrating from on-prem. You need to know your workloads and know what those IOPS and throughput numbers look like. And that's kind of a thing where a lot of people struggle. I will say with V2, it's easier to do that. Like I swear I've had to explain why you need to stripe disk in a storage spaces pool like 300 times, and still I see machines that look like just like an on-prem VM that have 20 single disk LUNs attached to them. Don't do that. And with Managed Disk V2, you can avoid that. But yeah, we can. We'll probably do another talk on Azure Storage more generally and some of the more developer-friendly features. John, is there anything you want to add about Managed Disk before you go away?
The only thing I would probably say is that if you do have a very nice shiny orange storage array in your data center, And I think Joey kind of mentioned it. You probably aren't going to get the same performance out of managed disks that you will that.
Yeah.
So make sure if you move from on-premise to Azure that you set your expectations correctly, because oftentimes I've run, and I know you and I both have run into clients where the performance is a little bit different, and they're going, "Well, we have this nice shiny orange thing," and yeah, it doesn't compare.
The one really interesting outcome of that testing I did last year, and not the orange vendor, but another vendor, NetApp, in AWS had really outstanding performance, and I was
Really?
shocked.
Nice.
Yeah, because their performance traditionally wasn't fantastic for database workloads, but I was seeing like 1-2 millisecond latencies in TPC.
That's awesome.
Yeah,
That's
and
awesome.
I know I've talked to like Argenis about it. They've done NetApp's done a lot of work in the cloud. Like they're the only vendor who, if you look at their reports, their financial reports, they actually report out their cloud revenue specifically, and it's like 10-15% of their company's earnings. So they've done well there. There's a lot more overhead involved. You're kind of managing. You're almost like managing a SAN. But if you're not happy with the performance of the managed disks that are available, that's something to look at. I'll include in the show notes a link to those couple of scripts we talked about on GitHub. I think they'll be pretty useful. And as
Awesome.
always, like and subscribe, and join us next time. Thanks.
See you in the next one.